Exponential functions are also known as exponential equations. In this video, we'll look at exponential functions, including what makes an exponential function exponential. We'll use tables and graphs to find and explain the relationship between two variables. Just as in any exponential expression, an exponential function has a base and an exponent. An exponential function is a function with a power in which the variable appears as part as the index or exponent. Exponential functions have the form y equals b to the power of x, or y equals a multiplied by b to the power of x, which can be written y equals a times b to the power of x, where a and b are both greater than 0 and b is not equal to 1. If b is greater than 1, the function is increasing, we have growth. If b is greater than 0 but less than 1, the function is decreasing, we have decay. Please refer to my other videos on growth and decay if you want further information on this. An example of an exponential function is the growth of bacteria. Some bacteria double every hour. If you started with 1 bacterium, you'd have 2 after 1 hour, 4 after 2 hours, 8 after 3 hours, and so on. Consider the following exponential function, y equals 2 to the power of x. This is 2 raised to the power of x. We can substitute values of x into the equation to find the corresponding values for y. We start with the x values between -3 and 3. We substitute them into the equation to find the corresponding y values. 2 to the power of -3 is 0.125 or 1/8. 2 to the power of 0 is 1. 2 to the power of 2 is 4, and so on. Notice that when x equals 0, y equals 1. Once we've constructed the table of values, we can use it to draw the graph of the function by plotting the corresponding x and y coordinates and joining the dots. This is all we'll use at this stage. In my graphing exponential functions videos, I'll show you additional techniques for graphing them. Notice that as x in green increases by 1, y is multiplied by 2 from top to bottom in the table. Consider the exponential function y equals 2 to the power of -x. We can substitute values of x into the equation to find the corresponding values of y. We start with x values between -3 and 3, substitute them into the equation to find the corresponding y values. Notice again that when x equals 0, y equals 1. Once we have constructed the table of values, we can use it to draw the graph of the function by plotting the corresponding x and y coordinates and joining the dots. Notice that as x in green increases by 1, y is divided by 2 from top to bottom in the table. This is because 2 to the power of -x is the same as 1 on 2 to the power of x. Consider the exponential function y equals 5 to the power of x. We substitute values of x into the equation to find the values of y, starting with -3 to 3. Substitute them into the equation to find the corresponding y values. Notice again that when x equals 0, y equals 1. Once we've constructed the table, we can use it to draw the graph of the function. Notice this time that as x in green increases by 1, y is multiplied by 5 from top to bottom. Now we have the exponential function y equals 3 times 2 to the power of x. We can substitute the values of x into the equation to find the corresponding values of y. We'll start with the x values between -3 and 3. We substitute them into the equation to find the corresponding y values. This time you might have noticed that when x equals 0, y equals 3. I've highlighted that in blue. Once we've constructed the table of values, we can use it to draw the graph of the function. Notice that as x in green increases by 1, y is multiplied by 2 this time, from left to right. The number in front of the 2 to the power of x didn't impact how much the y value increased. Now we have the function y equals 8 times 1/2 to the power of x. We can substitute values of x into the equation to find the corresponding values of y. We start with the x values between -3 and 3, substitute them into the equation to find the corresponding y values. This time when x equals 0, y equals 8. I've highlighted that in blue. Once we've constructed the table of values, we can use it to plot the graph. Notice that as x in green increases by 1, y is divided by 2 from left to right. The number in front of the half to the power of x didn't impact how much the y value decreased. From this video, we've established that for the exponential function, y equals a times b to the power of x. As x increases by 1, y is multiplied by b. In addition, the value of y when x equals 0 is a. Thank you.